first time when ISRO tried to launch the Gaganyaan atop a human-rated LVM-3 heavy LVM-3 rocket just a month ago, this is what happened.
Hold is observed.
But then, within an hour, they fixed the problem and launched Gaganyaan's first flight.
2, 1, 0.
This was one of the first major test missions of the Gaganyaan mission. The mission is called the First Development Flight Test Vehicle Mission and is one of the first of many test missions that are yet to come. In this mission, ISRO tried to demonstrate the in-flight abort of crew escape system at Mach 1.2 with the newly developed test vehicle followed by crew module separation and safe recovery. But this is just the start. The Gaganyaan project is a testament to India's prowess in space exploration. The vision is clear: demonstrate human spaceflight capabilities by sending a crew of 3 on a captivating orbit 400 kilometers above Earth for a mission lasting 3 days and ensuring a safe return of those 3 Indian astronauts with a splashdown in the vast expanse of the Indian Ocean. But before the grand performance of a human spaceflight, ISRO plans a series of precursor missions, each demonstrating a crucial piece of the puzzle. Test Vehicle Systems TVD1 to TVD4. These are single-stage liquid propulsion rockets equipped with a crew module and a crew escape system. They are meant to validate the performance and safety of the system before the actual launch of Gaganyaan. Only TVD1 was the mission that we just did. Uncrewed missions LVM-3G1 and LVM-3G2. These are 2 orbital flights using the geosynchronous satellite launch vehicle Mach 3 rocket with a robotic payload. They are meant to test the orbital module, life support system, environment control system, and re-entry technology. Crewed missions LVM-3G3 and LVM-3G4. These 2 are orbital flights using the GLSLV Mk3 rocket with a crew of 3 astronauts. They are meant to demonstrate India's capabilities to send humans to the low Earth orbit and bring them back safely. The manned flight and the final unmanned flight test will be done on the LVM-3 rocket, ISRO's well-proven and reliable heavy-lift launcher. It consists of solid stage, liquid stage, and cryogenic stage. All systems in LVM-3 launch vehicle are reconfigured to meet human rating requirements. Here, heavy LVM-3 will be capable of launching the orbital module to an intended low Earth orbit of 400 kilometers. It consists of a crew escape system powered by a set of quick-acting, high-burn rate solid motors, which ensures that crew module along with the crew is taken to a safe distance in case of an emergency either at the launch pad or during ascent phase. The final manned Gaganyaan will launch in quite a few stages. The first stage. The Gaganyaan will start burning the solid propulsion boosters. The mission will have 2 HS-200 boosters which will supply the thrust for liftoff. These HS-200 boosters are 20-meter long boosters with a diameter of 3.2 meters and is the world's second largest operational booster using solid propellant. Most of the heavy lifting will be done by these 2 boosters, then the liquid and cryogenic stages will come into effect. Once the rocket reaches the desired height, then it will separate from the orbital module. But there's a catch. If you look at the launch abort system, or in the case of Gaganyaan known as the crew escape system, it looks very similar to the launch abort system of SLS and other major space launch vehicles. A launch escape system or a launch abort system is a crew safety system connected to a space capsule. It is used in the event of a critical emergency to quickly separate the capsule from its launch vehicle in case of an emergency requiring the abort of the launch, such as an impending explosion. After all, a rocket is like a big missile without warheads. With the flight test being extremely successful, a few days ago, NASA Chief Bill Nielsen came to India. He also declared that NASA and ISRO are planning to send an Indian astronaut to the ISS next year. This is a huge development in the Indian space industry, as India plans to send astronauts on board Gaganyaan within a few years, and India also plans to make their own spacecraft by 2040. Now, let's see what went wrong during the first flight test of Gaganyaan TVT-1 mission. The first test flight of Gaganyaan mission was aborted at 8:45 am, October 21st, 2023, due to a problem in the engine ignition of the test vehicle. ISRO chief S. Somnath said that the ground computer detected a non-conformance and halted the launch sequence. However, ISRO quickly identified and corrected the issue and rescheduled the launch at 10 am. The second attempt was successful, and the crew escape system and the crew module performed as intended, which successfully demonstrated the safety and performance of the system before the actual launch of Gaganyaan. Well, as time passes, humans are slowly becoming a more advanced civilization, and our technology is becoming capable of achieving unimaginable achievements. As ISRO grows stronger, NASA is planning the next human moon missions under the Artemis program, which aims to land the first woman and the first person of color on the lunar surface by 2025. The program consists of several flight tests, uncrewed missions, and crewed missions using the Space Launch System rocket and the Orion spacecraft. The first crewed mission, Artemis II, is expected to launch in 2024 and orbit the moon. The second crewed mission, Artemis III, is expected to land on the moon in 2025 or 2026. The program also involves the construction of a lunar gateway, a space station that will orbit the moon and serve as a staging point for lunar exploration. Other countries that are planning or pursuing human moon missions includes China, Russia, India, Japan, and the European Union. China has announced its intentions to send taikonauts to the moon by 2030 and has already launched several robotic missions to explore the lunar surface and its far side. Russia has expressed interest in collaborating with China on lunar explorations and has proposed a joint lunar base called the International Lunar Research Station. India has successfully launched an orbiter and landed to the moon and plans to launch a human spaceflight program by 2035. Japan has also launched several lunar missions, orbiters, and plans to send astronauts to the moon by 2030 as part of the Artemis program. The European Union also has contributed to the development of the Orion spacecraft and the Lunar Gateway and plans to send European astronauts to the moon by 2025. Whew. As you can understand, very interesting times are ahead of us when it comes to space exploration. We'll someday discuss about SpaceX and other commercial space exploration achievements. Meanwhile, let's all hope that all of this is for peaceful and only for science development. And at the end of the day, humans will win, irrespective of country, creed, color, or anything else. Thanks for watching.